Welcome to the first video of Unit A, Real Numbers, Exponents, and Scientific Notation. This is going to cover Lesson 3 out of your textbook, Multiplying and Dividing Monomials. The focus of this video is going to be over knowing and applying the properties of integer exponents to generate numerical expressions. We're going to be learning how to do that by discovering a couple things. First off, we need to understand what a monomial is. Then we're going to dive into what is the product of powers, and then what is the quotient of powers. To start with, let's recall a little bit about exponents. 4 times 4 times 4 times 4 times 4. This expression can be simplified by creating an exponential expression. We can express it by saying that because it's a multiplication problem, we can take the base number and raise it to a power, an exponent. Well, we need to recall exactly what base and exponent are. A base is a repeated factor. In this case, 4. 4 is being repeated, so it's a base number. An exponent is how many times that number is being used. Well, it's being used 5 times here. So we can write that as an exponential expression, 4 to the 5th power, because it means 4 is being multiplied 5 times. So, what happens when we take a monomial expression and multiply it? Well, what is a monomial? A monomial is a number, a variable, or a product of a number and one or more variables. So here's some examples. A number, 1, 2, 31, 100. A variable, x, w, y, z, or a product of a number and one or more variables. 3z, 2r, 4xy, 7l, wh. Those are all monomials. Monomial means one term. Those are all one term. So we can take those examples right there and we can multiply them together. We can use exponent properties to simplify monomials. The exponent properties we're going to be working with are listed here. The two we're going to focus on for this video are the product of powers and the quotient of powers. So let's start with the product of powers. The product of powers means exactly what it says, product. Product means multiplying. So we're taking two monomials and multiplying them together. So let's start with a simple one. 2 to the 4th times 2 to the 3rd. The only way this works is if the base numbers are the same. They have to be the same, otherwise this does not apply to it. So 2 to the 4th times 2 to the 3rd, they're both the same base number. And what I'm going to do with that is I'm going to take the exponents and I'm going to add them together to give me a new expression. That gives me 2 to the 7th power. 4 plus 3 is 7. Let's look at another simple example. 5 to the 2nd times 5. Whenever we see a number or a variable that does not have an exponent on it, it's like we say it is to the 1st power. Meaning how many are there? There's only 1. So we can say the exponent there is 1. So we can rewrite it saying that we have 5 to the 2nd times 5 to the 1st. Now we have two monomials that we can multiply together, knowing that we have two variables to add together now, 2 and 1. 5 to the 2nd plus 1 gives us 5 to the 3rd. Or you can expand it out saying 5 to the 3rd is equal to 125. Sometimes you can get away with doing that because they're small. Sometimes they get a larger. Not so easy to do. Let's look when we have a variable. Say we have c to the 3rd times c to the 5th. Well, same rules apply. I have a base number of c. I'm going to add the exponents, 3 and 5 together. When I do that, I get c to the 8th power. I might be going a little fast here, so if you need to pause it, please do so. So we have in this expression negative 3x to the 2nd times 4x to the 5th. Well, I only have two like bases here, x. So I'm going to take the negative 3 and 4 and move it out to the front, multiply them together, and then I'll take my base number and add the exponents. I get negative 12x to the 2 plus 5, or simply negative 12x to the 7th. When we divide monomials, it is known as the quotient of product, meaning if I have the same base number in the numerator and the denominator, I can subtract the exponents. So here in this example, I have a base number of 5. I'm going to subtract 7 and 4 together, so 7 minus 4. It's always the top one minus the bottom one. That way I get 5 to the third. What is the reason behind adding and subtracting? Well, let's start with multiplication. When we look at multiplication, we need to look at actually what the expression is saying. So we have this example here, 9 to the third times 9 to the second. Well, what exactly is that really saying? It's saying that we have 9 times 9 times 9 being multiplied by 9 times 9. Well, stop right there. How many do we have altogether? There's a total of 5 9s there. We know that we can rewrite any multiplication expression of the same base as a exponential expression, 9 to the 5th. So I can actually sit there and see that 9 to the third plus 2 is the same thing as saying 9 to the 5th. Now let's look at a division problem. I have 4 to the 8th over 4 to the 2nd. Well, how can I elaborate on this? Start off by what it's saying. 4 to the 8th means I have 8 4s in the numerator being multiplied together, and 4 to the 2nd means I have 2 in the denominator being multiplied together. We need to recall with a fraction, anytime we have a common number in the numerator and denominator, they will cancel out, leaving us with 1, the number 1. So how many 4s will cancel out about the numerator and the denominator here? Well, 4 will cancel out twice here in both the numerator and the denominator, leaving us with only 6 4s in the numerator and nothing in the denominator, simplifying it down to 4 to the 6th power. So let's look at multiplying and dividing monomials with coefficient and or variables. Well, what is a coefficient and what exactly is a variable? Hopefully you know it. If you don't, that's fine. That's why I'm doing this. A coefficient is a number that is in front of a variable. So it's any number that's in front of a variable. Well, what's a variable? It's a letter that is used to represent some unknown number. So when we multiply and divide them, all the same rules apply, but the coefficient numbers that are out in front, they're going to be done separately. They're going to be calculated together away from the variable or the numerical base number that we have. So let me put it as an example to try and clarify what I mean by that. Let's start with multiplying. We're going to multiply variables together first. A to the third times a to the second. Same rules apply. I'm adding the exponents with the same base number. The base here is a, so I have a to the 5th. Now here's one with coefficients and variables. Well, I'm going to take those coefficients out in the front and multiply them together because I can just do that. That's just a normal expression. But I'm going to keep the like base of m separate and use my exponent rule of multiplying like expressions together, meaning we're going to add the exponents. So I have negative 2 times 8 gives me positive 16. Then I have m to the first plus 5 gives me 16m to the 6th power. So let's look at division now. Once again, we'll just start with a simple variable expression. X to the 10th over x to the 5th. Same rules apply for the quotient power. X to the 10th minus 5 gives me x to the 5th. Now let's look at one with a coefficient in there. 12w to the 5th over 3w to the 2nd. Once again, I'm going to separate my coefficients separate from my variable. Now I have 12 over 3 times w to the 5th over w to the 2nd. 12 over 3 is 4. Division. Easy enough for you, I hope. W to the 5th over w to the 2nd. I have my quotient of powers rule, meaning I'm going to subtract 5 and 2 together. Gives me 4w to the 3rd. Once again, if I'm going too fast, please pause the video and go back and review it. Time to try it. Try these expressions by simplifying them to the lowest expression they can go into. 4 to the 5th times 4 to the 3rd. Negative 2a times 3a to the 4th. Y to the 8th over y to the 5th. And 24k to the 9th over 6k to the 6th. So pause the video, take a moment to do these, and when you're done with them, start the video over again. And if you're not sure, go rewind the video and go check it out again, or put your name on the help board, and I will come and help you. All right, let's check your answers and see how you did. For the first one, we have 4 to the 5th plus 3. That gives us 4 to the 8th. For the second one, my coefficients on the front need to be computed together, meaning I have negative 2 times 3, which gives me negative 6. Then I have a times a to the 4th, which gives me a to the 5th. So my final answer is negative 6 a to the 5th. For number 3, I get y to the 3rd. And for number 4, I get 4k to the 3rd. Once again, the coefficients get separated from them, compute them first, and then we do the variable expression of k to the 9th over k to the 6th. If you need more help, please sign up on the help board.